move on to our main session today. We were excited to see Consumer Reports come out this spring with their first report on heat pump water heaters. And so we've been chatting with them and asked them to come on to the AWHI Residential Working Group to talk us about why heat pump water heaters, why now, and what went into their testing and ranking. So without further ado, I'd like to welcome Bernie and John on from the Consumer Reports team to chat with us about their report. Bernie, over to you. Actually, it's over to John.
Oh, yeah, so Joe, yeah, I'm going to do a couple of intro slides. I'm not sure how familiar the group is with Consumer Reports. I just want to start by saying thank you for inviting us. We appreciate the opportunity. So Consumer Reports, who are we? We're an independent nonprofit organization. We work with consumers. I think the real takeaway from this slide is we're nonprofit. A lot of people don't realize that. We don't take any ads. I mean, you may see an ad in the Subaru commercials, but that they're licensing our rating. So it's not an ad on our products. It's kind of a licensing agreement. And then the other thing that's important is we don't take any free samples. So everything we test is purchased through anonymous shoppers who go out into the market, just like any other consumer, and buy the products. So that's kind of who we are and some of the facts. I just wanted to also go over how we rate things. And there's really two different things you'll be seeing. One is, if you look at the top part, the ratings, it's from worst to better. And in a lot of the print publications, you'll see those, what we call chevrons. You know, obviously on the left is red is the worst. If you go to the right, it's better. If you look at some of the digital products, you'll see it on a 1 to 5 scale. Kind of makes sense as well. And then the other thing that's kind of a nuance within this is that these are buckets. So each of these buckets have a range of scores. So a lot of times, somebody will see something that there's 2 scores of 5 and they think they're exactly the same, and they're not. There's slight differences. We need to do some math behind the scenes to get you an overall score for presenting in 5 different distinct buckets, but there is actually some small differences within those buckets of information. If we go to the next slide, just some information about Consumer Reports. We have 9 million unique visitors to our website each month. Those are paid members. Our members actually support Consumer Reports. That's how we get our primary sourcing for funding. It's members. We spend over $33 million a year to test products. That doesn't account for the editorial staff and all the other things that we do. It's just for the testing staff and the products we buy. Consumer Reports was founded in 1936. So we're 89 years old. If I did the math right, I hope I did. We have 63 state-of-the-art labs. We're actually in Yonkers, New York. If you're not familiar with New York, that's about 25 minutes north of Midtown Manhattan. So we're pretty close to the city. We get a lot of our editorial staff who actually live in the city. We do have an auto test center, which is not in Yonkers. It's about 2 hours northeast of Yonkers, and that's in Connecticut. And it's a huge facility, 327 acres. We have over 550 employees at Consumer Reports at this point. A couple of the ways we reach consumers is, believe it or not, there is still a print magazine. And we do have, I think it's close to 2 million members who still subscribe to the magazine. So it's still something that, for some reason, the type of people who want information about products, they're still going to print. Obviously, we have our website and we have some mobile apps. Of course, we're on all the social media platforms, different kinds of outreach too. The other thing that's not mentioned here is we also have advocacy offices. So they actually go to try to pass legislation, anything that we see, or if there's any safety issues, we have a way to kind of access lawmakers to try and make changes at that level. So next, I'm going to pass it to Bernie Dietrich. You can introduce yourself and take it from there.
Okay, hold on. Let me take control. And here we go. Okay, so my name is Bernie Dietrich. I am a test engineer. My background is
Bernie,
chemical
real quick,
engineering.
Sorry to interrupt you. Before your camera was on, I just want to let you know your camera is not on right now.
Okay, I'll turn my camera back on. So I am an engineer. I have a bachelor's and master's in chemical engineering, which I do not do any chemical engineering anymore. It's basically data collection and analysis of the products that we test. My official title is Senior Test Program Leader. I'm the most senior technical member of the staff at Consumer Reports. I've been doing this for over 30 years, 34 actually. So my job is to come up with a way to evaluate products. And typically those are products that we've never tested before. We have tested water heaters before, and that kind of informed the tests that we did on the heat pump water heaters. We had tested gas and electric water heaters and basically found that there was no real difference in their performance, a meaningful difference. So, what the warranty was really what differentiated it. So I was asked to test heat pump water heaters. And so whenever I design a test, the first thing I think about is what's important to the consumer. Okay, somebody who is using a heat pump water heater is interested in having hot water, obviously. They're interested in the performance, but they're interested in energy saving. And so in discussion with my managers and the writers, we decided that the way that we would evaluate this specific product is through the use of the heat pump only, which is the most energy efficient methodology. So those are the things that consumers worry about: having hot water, having low energy consumption. So those are what we decided to test based on. Every hot water heater that we tested, the heat pump, came with an energy guide, basically, that was, the claim of their energy use as well as their capacity. And so we did not verify those things because they were already lab verified. So if a model said that it had 51 gallon capacity, we believed it. So we didn't put it on a scale and fill it with water and see how much water it actually held. We also wanted to test in a way that we would not be doing judgments. Sometimes we have things like the taste of something. You have to have panelists and you get a bunch of different products. You test them, you taste them, you give a lot of opinions, and we don't want to have any opinions. So we set up a test program that was data centric, where we would collect actual data. So the other thing is, we did not, when we evaluate these, we don't look at what the customer choice, how it affects that. So for example, for hot water heaters, you have different capacities. So the evaluation that we did was independent of the capacity of the tank. So that means that, for example, the first hour rating, which is really dependent on the size of the tank, we did not use that in our selection or our scoring criteria. So we primarily looked at those differences that were performance based. And then we also want to make meaningful differences between these things. So small differences, we don't want to have, a model that scores very differently based on a small difference. So when we come up with a scoring procedure, we want to have continuous differentiation, so that if there a small difference in performance is not it leads to a small difference in score. And when we tested these, we tried to control the variables. The water quality. We use the same water. We use the same electrical supply. We test them one at a time. We did multiple tests on them so that we would be able to replicate our tests and make sure that the conditions did not affect the results. And we tested them in the same way. So that our test procedure would have as little effect on the outcome as possible. So here's a picture of basically our test setup. This is, this picture was actually tested or taken
Bernie,
before we.
Bernie, we're not seeing the same slides as you. I don't think I'm not anyway. Is everybody else seeing them?
I'm seeing it.
Okay.
I'm seeing the A.O. Smith side. Sometimes it can be varying for different people, but are you on the A.O. Smith side, Bernie?
I am. I don't know what model that is. I don't pay attention to brand. That's one of the things that I do is we assign numbers to models as they come in and everything is coded. So I honestly have no idea what model that is. Anyways, the picture shows.
Reminder to folks to please mute yourselves.
A.O. Smith H.
Okay. So this picture was taken when we first started doing the test, and it shows the water heater installed with we use hoses to connect to make it easy. We have a data collection unit, which is to the left, measures temperatures, measures water flow, measures electrical, the voltage and the current, and it stores that data every second. So one thing that's not shown is we made a modification to the plumbing, which would allow us to circulate the water from the inlet to the outlet to get an average tank temperature. We did not install a thermocouple into the tank because of the different configurations. We had the thermocouple on the inlet and the outlet. And I'll go over that in a little bit. So every second, these are the things we measured and the air temperature. So we started with the water heater completely empty, de-energized, and we filled it with cold water. When it was completely filled, we circulated the water using a circulating pump to get an average cold water temperature. Our water system is controlled, but I wanted to get a more accurate temperature depending on the residual heat within the water heater, as well as the room conditions. So we would circulate to get the average cold water temperature. Once that was steady, we would energize the water heater and operate it in heat pump only mode. That was to evaluate only in the heat pump mode, which is the most energy efficient and really the reason why we think people should have these water heaters. So once the thermostat was satisfied and the unit shut off, we would de-energize it and we would circulate water again to get an average hot water temperature. And that's so that we could do a calculation, figure out how much actual energy was put into the water to get an estimate of what the energy factor is, how much energy was used, how much energy was available to get that ratio. So this is a typical chart of the wattage. The compressor turns on, we got a short spike. The wattage ramps up over the time. Once the temperature is satisfied, the heat pump turns off and the wattage returns to zero. We would basically calculate the total energy used by the unit, as well as the temperature. So now this temperature curve, you see this discontinuity. That's where we turned on the circulation system after the temperatures were satisfied, and to get the average temperature, and you can see that it's slightly over 120. We used 120 as our target temperature, and we had this approximately 60-degree water inlet temperature. That temperature rise times the volume of the claimed volume of the tank is, we would calculate the actual energy put into the water in joules, and then calculate the ratio based on the actual watt hours used to confirm what the manufacturers claim on the energy factor, because it's, the energy factor, the way that it is calculated, it depends on a different type of draw schedule. So we didn't want to have to replicate that draw schedule. So this was just a confirmation of what the claimed energy factors were. So after we got all that data, we calculated the energy used in watt hours, calculated the BTUs, calculated the ratio to confirm the claim of the manufacturer. And then this was a big differentiator, was the speed of heating in BTUs per hour. So because these are storage units, they're pretty well insulated. So there's really not a huge energy penalty to having them heat up quickly. But there is a big advantage to the consumer to have them heat up quickly. They recover more quickly. They may have a slightly longer operation time before they run out of cold water. So the times when your kids get home from college, they're less likely to complain. And the longer you can stay in the heat pump only mode operation. So all that together, we came up with the ratings. We scored the energy efficiency based on the manufacturer's claim. We scored the speed of heating, which was based on our calculation. And then we looked at the ease of use issues with all of these. Did they have controls easy to use? Some models, actually, you had to select the mode on installation and it wasn't changeable. It was internal dip switches. So that kind of thing is not easy to do. Did it come with a tempering valve so that you could change the temperature to increase the actual capacity of the tank, the effective capacity rather, things like that. So we would score the ease of use. And then we ignored a lot of things like noise, like the dehumidification, the condensate water handling. And then we had some adjustments based on factors that we noticed in the testing. This is a big one, which was atypical wattage usage. That means that this unit, though it was operated in heat pump only mode, turned on the internal heaters. As a consumer, I'm completely unaware that this is happening, but it affects my energy use. Ignoring this part of the resistive heating element usage really would throw off my understanding of how much energy I'm using. The fact that this came on when the water was cold rather than just going into heat pump only mode had a huge impact on the energy efficiency. The speed of heating for this unit, we did calculate it based on just the heat pump only, the part after the resistive heaters turned off, but a model that had this sort of energy profile, because it's not under the control of the consumer and the consumer thinks it's in heat pump only mode, we adjusted the scores down because of that. So this isn't what we actually ended up publishing then. So we have an overall score. This top model got a 94. It's a recommended model. It has excellent energy efficiency, excellent speed heating. It was by far the fastest one, which is why there's a large gap between these two. And then just some information that the consumers would be interested in reading about. So after I'm done testing and have that ratings, our writers take that information and they write a story. They have a buying guide typically, which kind of highlights what's important when you're making a decision in choosing which type of water heater, not the specific water heater, but the type of water heater. The only ones that we have ratings are for heat pump water heaters, because there's so little difference in the energy use within electric storage water heaters, for example. Energy use is primarily based on your hot water usage. So we don't have ratings for any other water heaters other than the heat pump water heaters. So that's basically how we tested them. If anyone has any questions, I'll be happy to answer them. The speed of heating, we measured the rise in temperature of the water. So it's basically BTUs and BTUs per hour. So the top one was over 11,000 BTUs per hour. And then some were as low as, I think 4,000 BTUs per hour. I forget the exact numbers, but it was basically BTUs per hour.
Where would you take that temperature measurement?
We had the thermocouple at the outlet, but we would circulate the water until the tank was at a uniform temperature, which means that the outlet temperature is not changing over time. Yeah, I realize that there may be stratification within the tank, so I wanted to get an idea of what the average temperature within the tank was so that I could get the total energy used. The first few tests that I did, I just looked at the temperature on the outlet, but then it would start to drop. And I realized that, while the water was still warm, I wasn't getting a good estimate of the actual energy put into the water. So that's why I did the circulation until the temperature was consistent.
Thanks for that. Go ahead, Ben.
Thanks for the presentation, Bernie. Wondering what your methodology was around controlling the temperature and the humidity of the source air, both for the unitary systems and for the split system that is typically has an outdoor component, what the conditions there were for temperature and relative humidity of the source air.
We installed the units in our lab, which is temperature controlled, fairly tight. I did measure the air temperature and I did not measure the humidity. All the tests were done within a short period of time, so that there wasn't a big impact of the change in the seasons. So the lab temperature was very consistent based on measurement, and that part was not you know, the energy factor was based on the manufacturer's claim, which was done probably in a lab that had better control over those factors.
Thanks.
Any other questions?
Yeah, as we're waiting for folks, I think we will get some, we encourage, feedback on the test or other questions that folks are interested in. What went into the decision to, focus on certain, I mean, you explained a little bit on the energy efficiency, but why not add noise to the ranking system? What went into some of the decisions around stuff that you didn't measure and rank?
Well, we typically measure noise when a unit is in the living space. So this would be down in your utility room, where noise is really not a big issue. So we decided that we just would not factor noise into the score. It's as simple as the fact that they're out of sight, out of mind units, basically.
I'll have to follow up. I think it's largely true, yeah, that and we have some good members of our group who have better data on exactly where water heaters are located, and largely, garages and basements are the common areas. But there is a decent percentage of folks who have water heaters in their utility closet, so it might be a factor to consider in the next round. But we'll follow up with that exact percentage.
And when we operated them, there was not a huge, there was nothing that stood out in terms of noise.
Interesting.
So they all
Good.
seem relatively similar, and if they're in a closet or down the basement, it wouldn't have an issue.
That's super. Well, that seems like great news then. Yeah. Bernie, another question. You talked about the resistive heating elements coming on in some models. Just in general, did you see that a lot when they were in heat pump mode? Any comments on how often that resistive heating was coming on?
No, it was we tested two of the models that we tested had that type of performance issue.
Okay.
So neither of those units is recommended for that reason. The idea of buying a heat pump water heater and choosing to have it operate in heat pump only mode. Can everybody hear me? I'm getting a lot of buzzing.
Yeah.
Yeah, we're getting it too.
Okay. So anyways, okay, everything's better. So the fact that they don't operate in heat pump only mode when I'm telling it to operate in heat pump only mode, I understand that there's a trade-off in performance when I choose that mode, but I also realize that it's the most energy efficient. So those units that did not honor my choice, I don't think they're as good a choice as other units that did operate only in heat pump mode when so set. And so it's just, I think that's it's kind of not underhanded. It's kind of a sneaky energy use that I would never be aware of if I had that unit. So that's why we ding those units for that type of performance.
Sorry, I think I was the culprit with the buzzing. I apologize for that. I'll make sure to mute. Question, what's been the response to, your first heat pump water heater? Are you finding your members have taken interest in this, or are you getting feedback from other folks that, oh, you might have done this or done that? What kind of response have you gotten since coming out with these rankings?
We haven't gotten any specific feedback on these. But what we do is track the number of visits. We track the number of times that members follow the shopping links. We track the number of times that people who visit these pages sign up to be subscribers. And so those metrics will be analyzed over the next 5 or 6 months. And that will weigh into our decision as to whether we should expand these ratings, redo them, do them a little more fully. Our mission basically is to get as simple a test that differentiates models to see whether those projects are of interest to our readers. And then if they are, we will expand the tests, we'll test more models, and it may even become an annual type of test as more and more of these models come out.
Well, we're hoping there are enough nerds out there like us, like this group, to get you a lot of folks reading the reviews and clicking and becoming members. I had another question, and folks do feel free to. I'll check the chat if I'm missing anything. Are you open to, in other technologies? Have you found a way to test performance over time, and could that be a potential one for the future? You've shown energy efficiency performance, but what if some models have poor performance and more breakdowns over time? Can you test that, and can you rank that in the future?
The way that we do that is we survey our readers who own the devices and ask them. It's a reliability and satisfaction survey. So basically, we need to have a number of our readers who have the devices, that have had them for a number of years often, and are willing to respond to a survey. So a lot of our products where we have good data, we have incorporated the reliability and satisfaction scores into the overall scores. So reliability is often a heavily weighted factor for refrigerators, for example, which is one of our largest categories. It makes up almost 20% of the score, the reliability. And it's an important differentiator within the category. Since this is a category that we haven't tested before, we don't have that type of information yet. But if it does become a category that we test over time, we will likely add reliability through the survey, which is really one of the unique things that Consumer Reports does, getting our surveys to give us that type of data. Our statistics team does a fantastic analysis and gives us scores that we're able to use to differentiate models within the category.
That'd be great. That sounds super valuable. Yeah, if that happens in the future. I am missing some questions that were in the chat. How many different manufacturers did you test? Someone's asking.
I think we had 10 different manufacturers. The one that we missed was GE because their model wasn't out yet. And I mean, there's been some discussion as to whether we should go back and revisit that or wait until we get the readership values to see whether it's something that we want to do.
Great. Someone else is asking, where do the shopping links go to?
The shopping links go to...
Bernie, I can help you out with that one.
Yeah.
So we have an affiliate program with like several different retailers. So if you clicked on one of those water heaters and, for example, if it's sold at Home Depot or Lowe's, it'll take you directly to their website to that water heater. Unfortunately, this is a category where there's some odd names that are not going to be sold at home centers like that. So it'll probably just take you to a generic Amazon link, which is not going to work, unfortunately.
Okay, thanks for that. Someone else asking, did the heat pump water heaters that the sneaky electric resistance energy usage have a noticeable or significant increased usage over the others? Maybe overall usage of energy?
Yeah, I mean, you can look at that graph. So this is the low part is the heat pump. It was using over 5,000 watts. It had both of the electrical heating elements energized for a fairly long time. I don't have those numbers on the tip of my tongue, but that was part of the analysis. So yes, it was a significant amount, and that it was also, we weren't using very, very cold water. We were using 60-degree water as the input. So, if you lived in an area that had very cold water, say in the winter, and you filled it with, high 30-degree water, it may be an even greater fraction of the energy used. We also did not investigate when this actually would turn on. It would, if you had it in heat pump mode and you drained half the tank or 3/4 of the tank rather than the whole tank. So we did not look further into this. We just noted that when it was completely filled with 60-degree water, those heating elements would come on despite the fact that it was heat pump only mode.
Okay. Well, Bernie, John, thank you so much. If you all are able to stay around and see if I missed any questions in the chat, we'd love that. And also, we'll try to put a link, or if you all have one handy for the actual news release on this, that would be great. And folks, go subscribe to Consumer Reports and encourage them to keep testing heat pump water heaters. We'd love to have additional years and testings and models. We'd love for this to be a product class that you continue to test year over year. So we'll do what we can to help promote that. But thank you all for coming on. Really appreciate you testing heat pump water heaters and chatting about it with us. So thanks so much.
Thank you.